And welcome to another Commodore 64 assembly language programming video. God, it's been a while, hasn't it? But yes, I'm back and I'm continuing the series. So rather than give you sorry excuses and go on and on about the reasons I haven't been able to do it, let's just crack straight on with it. Right, let's go and look at our last video, which is video 10. Okay, and this is where we actually used CarPad, which is here, to build a set of characters and a map. And then what we did is let's just run this, and on our 64, yeah, it displays the map on our screen. Perfect. But then we looked at, now we know how to do this. What if we want to scroll it? So, okay, today we're going to look at horizontal scrolling. And this will be part one because there's going to be two parts to this, because to do it properly with using the hardware smooth scrolling features of the VIC-2 chip, we're going to have to do quite a lot. So this will be part one. So we'll get some scrolling going. And then part two video is we'll finish it off and make it, nice and smooth. Right, so what I've done, just for the sake of this video, is in CarPad, as you can see here, I've changed the resolution of this to 256 by 25 instead of 40 by 25. And you do that by literally just changing what you want in this box and then hitting enter. And then I just used a bit of copying and pasting to sort of make the map nice and long like this. Okay. So yeah, there's a little bit of variety there, and then we've got a gap, so we know we're sort of nearing the end, and when we've just got a single line bit of platform there. So just so we know that we're nearing the end of it. Okay, right. So if we remember on video 10, we exported it all to ASM. Okay, which you've got here. So we've got our custom characters here. We've got our map here called the map, and it's quite big. And then we've got our character attribute data. So character 1 is this color and this multicolor option. So this is on a per character basis. So we won't have that many. Depends how many custom characters we got. Okay, but this slide is big, very big, and it's going to be even bigger when we import a new sort of wider one. Okay, but I'm going to show you a way to get around that. Okay, so we've got a brand new file here for video 11. So let's do our standard things here. So let's get our basic loader in. So I'll do that there. Just zoom in a bit for you. And we're going to start at 1000, and the first thing we need to do is stop the interrupts for a minute while we do a few things like setting up the VIC chip to how we want, setting up the screen mode, etc., etc. So I think the first thing we'll do is we'll turn off the interrupts, because we don't need all the extra interrupts, because we're going to turn off the kernel in the basic anyway, because we want to use the RAM there. I believe I may have covered it in a previous video, but I'll run over it quickly in this one as well. So turning off the interrupts, we know what to do with that because we've covered that definitely on the video. So we just load 7F, the accumulator, store it in the interrupt reg, the first one and the second one. Okay, and we've done that before. Right, so the next one is multicolor mode. Okay, and for that we will load in the accumulator what's in the VIC control register. Okay, and we've covered this on a quite a recent video, all the different color modes. Okay, we'll all it with 16, so we'll set the bits we want. That's No, it is just one bit, so it's decimal 16 or binary 0001000. Yeah. So okay, but we've covered all that, and we'll store that accumulator back into the VIC control register. So that should give us multicolour mode, and it's turned the interrupts off. Okay, so now what we want to do is we want to turn off the basic ROM and the kernel ROM, because we don't want to use any of that, because we want to use that memory for our map and our code and character set. And obviously we've only got 64, so we're fairly limited. Okay, so let's turn off basic and kernel for the Commodore. Okay, so it's fallen off. Oh, I'm tearing it off pretty much. Okay, so let me quickly explain how we do that. I mean, we may have covered it, but I'll quickly explain how we do that. So I'll flick over to the memory map. Okay, here we are. So, okay, so memory address 1, hex 1, decimal 1, binary 1. Okay, we're interested in these 3 bits here, 0, 1, and 2. Okay, so if we set this to X00, the RAM is available in all the areas. If we set it to whatever and 01, the RAM is visible here. That means basically that means there's no kernel or basic using this memory. And I know the kernel particularly uses these. Okay, we set it to 10 is visible here, and the kernel ROM is visible here. Okay. If we set it to 11, basic ROM is visible here, and the kernel ROM is visible here. This is the default. Okay, so basic's available and the kernel's available. This one, the character ROM is visible here. We don't really want to do that because we've got our own custom character ROM we're going to store in the VIC bank. And then 1 and whatever IO area is visible in here. Okay, so I think we'll keep that. Okay, we'll have 1 and 01. Okay, so we've got this RAM here, this RAM here, and we're not too worried about this. Okay. So what we want to basically put the value of 3, 4, and 5, don't matter, that's all to do with a cassette tape, so we don't really care about that. That's the default. So we ideally want I think 101, I believe. Let's have a look on our calculator. Now, I was messing around and I did 35, which did those to the tape because I think that's what's already set, which is these two, and it does 101 here. Okay. So it keeps the dataset motor on there basically. So let's load 35 hex. Okay, or this binary is fine. Okay, so we'll copy that up to here. Let's zoom in. So if we're loading binary, we load, it's a number, not memory address. And we do it like that. So that's our number, and we're going to store that in 01. We don't have to put 0001 because it is a 0-page address because it starts with 00. Okay, so that will turn off basic and kernel and everything. All that RAM is free for us to do what we want with. Okay, so the next thing we want to do is choose VIC bank high address. So we want it quite high up in the C64's memory, not sort of low down. Okay, so we look at this using memory address D018, which is our VIC bank pointer. So let's flick back to the memory map. and show you what I mean. Okay, here we go. This is the VIC bank pointer. It was DD00. I've got this in my VIC2 constants file, so we don't have to remember this number. Okay, so if we look at this, bank 0 is the VIC memory is from 0 to 3FF, which I think is the default. If we switch bank to bank 2, and this is done by just these first 2 bits here, okay, bit 0 and 1. So bank 1 puts the VIC in this area, and it goes up by 8,000 hex each time. In this area, then this area here for bank 3. So we want as high as possible, so we're going to go for bank 3. So we need to set the bits 0 and 1 of the of this address to 0, 0. So let's do that. And we pretty much don't care about the rest of it. It's all to do with serial bus. So C0000. So because we don't care about the other bits, because that's just for the serial bus, we'll load 0 into the who does that? 0 into the accumulator, and we will store that in the VIC bank pointer. Okay, and that is in our VIC2 constants. Okay, and that points to DD00. Okay, so that means we can put a label in here, because our normal screen memory label will point to 0400, which in hex, or 1024 in decimal, but we've moved it all, so we're going to put a label in here. Screen RAM equals, so the screen memory will start here. Okay, so the next thing is the character bank, and that is another VIC address that we're going to look. I think it's D018, and we've got to set some bits in that as well, so that our character memory is at the right place. Well, our VIC is pointing at the right part of memory to get our custom characters. So let's flick back. Okay, here we go. So D018. Okay, so let's have a look at what we've got here. So this is relative to the VIC bank address, okay, which is in D00. So we are at C00. So we want, and if you notice, this is bits 1 to 3. Okay, I think bit 0 is used as a carry bit for something else. I can't quite remember. So 1 to 3. So we want, forget, there's a number after that. We want 800, because 800 hex is plenty for the screen RAM. The screen RAM is only 1024 in decimal, so it's going to be even less in hex. So 800 is a good place for the character RAM to start, the custom character RAM to start. So we need to set basically 0010. Okay, because don't forget, bit 0 is not included in this, so we've got to include that. So 0010 binary. We'll set that into this address here, and that will put our character ROM to point to C800 hex, nice and high up. So let's flick back to our code. Point character RAM, or custom character RAM, to VIC plus 800, and in brackets C800. Okay, we do that simply by loading, and we can go binary here. So it's a number, it's binary, and we can just do 0, 1, 0. Okay. We could do the full length. We could do full length of it here. Let's check we got the right amount. Yeah, we can do that. And we'll store that in the graphics pointer, which points to D018 in our VIC2 constants. Okay. Next thing we need to do is we need to put the screen into 38 column mode. Okay, so as you know, it's 40 wide. And what it will do, the screen will narrow slightly by one column on the left and one column on the right, in order for us to have a column to use for our scrolling buffer, okay, that is invisible. Okay, so we do that by going to the VIC control register, which if we look in our VIC2 constants, is D016, and we can have a quick look on the memory map. Okay, here we are, D016. Bits 0 to 2, 0, 1 and 2, the first three are used for the hardware scrolling. We'll be covering that in part 2. Bit 3 is what we want, okay, which gives us 0 for 38 and 1 for 40. Multicolour mode we've already done anyway. Okay. So we actually could have done this at the same time, but no, we'll do it normally, separately, just for the just so we can get an idea of the things involved. Right, let's flick back to the code. Okay. Right. So set to 38 column mode. So what we do is we load what's in the VIC control register. And it, because we want to turn that bit off. Let's get a binary, so we and it, so it preserves everything else, but turns this bit off, okay? And you know how AND works, whether each bit has got a 0 or 1, it will keep that, except this one, it will have a 0 regardless. Okay, and it'll preserve everything else. So we're going to turn that bit off, and then we'll store that back in the VIC control register. Okay. So let's just set up our colours. Okay, so I know what the colours are for our I know what colours we've used because they're the same as the last video. So what we'll do is we'll load in black, and we'll store that in the border colour. Then we'll load in cyan. We'll store that in the screen colour. As I said before, my mixture of the American and English words of colour. That's because I copied some of the constants from an online source, which was obviously done in an American language. So that's why we've got the mixture. And I do keep meaning to make them all consistent, but I haven't got down to it. Okay, so red is our colour 1. Load red and store it into text colour 1. Then we'll load yellow. And we'll store that into text colour 2. It's TXT. Text colour 2. Okay, so now we can clear the disable the interrupt stop, and for now we'll RTS and go back to basic. Okay, so this is just initializing everything. Let's just make sure we haven't made any. Let's just put a comment in here. Set colors. Okay, so let's just run that on R64. STA doesn't support immediate mode. What have I done? Oh. Line 15. Oh, don't know why I've got that hash there. Let's try again. Oh, 38. I've done the same thing. So I'm trying to store it into a number rather than into a memory address. Okay. Finally. Okay, it's done then. It's returned us back. It didn't seem to change the colours much. Let's just try. Let's create a loop. Okay. Loop and minus, because it's an exclamation loop. The minus means we're going minus to it. So this will just be stuck in an infinite loop here. Okay, well, let's just save that and run it. So hopefully we should get our colours. Yeah, there we go. There's our colours, and yeah, everything is garbled on the screen because because we've moved the character and the screen RAM around to an area that's got nothing in it, or just junk in it. Okay, so we're all set up. Now let's look at how we're going to draw our map. Now, if we look in here, this is last week's video, or last week's, last year's, or whatever. Okay, this is the previous video, but what we did is we loaded from the map and stored it in the screen memory, but we did it 256 bytes at a time. Okay, but obviously each time covered multiple rows, so each loop covered multiple rows. Okay, however, we can't do that with a scrolling. We've got to do it line by line. Yeah, that's right, line by line. Because imagine, let's flick back to the card pad. Okay, so with a 40 by 25, once you get to 40, character 41 is here. Okay, and we don't want that. Okay, because when we get to 40, we want to get to the next line, which is not 41, it's 200, and so there's 0 to 255 here. It'll be 256. So that's character 0, that's character 256, but on the screen memory, that's character 0, and that's character 40 in decimal. So this is why we've got to do it line by line. Okay, and I'm going to use a new technique to do this. We can close R64. Right, so first of all, let's load in our map. Okay, so we'll pop the map in, say, about 8,000. We'll start our map at 8,000. Okay, and instead of pasting everything from assembly, what I'm going to do is I'm going to export this as a binary. Okay, and I'm going to export the map 8-bit as a binary. Okay, and then I will store that in my area. Okay, so let's just switch back and jump cut until I've done that. Okay, so as you can see, I'll put it in a folder here called assets. There's my bin file. So what I'll do, we'll call this the map again. And that's our label for where we want it. And the way Kick assembler works to import binaries is you do dot import binary. Okay, and it's in current folder, assets, and vid 11-map.p. Okay, so there's our map. Custom characters are next. Custom characters. Okay, we'll put these directly into where the memory is pointing to. So that's C800. And because it's not that big, and we're using the same ones, we'll just paste it out of here. It's these here. Okay, so we'll paste custom characters here. Oh, we've got to do the character attributes, haven't we? Let's just tidy this up. Which is the color settings and everything. So they are down here. Let's just copy that. Okay, and we will put that underneath the map. I can go straight after the map. But there are character color data, custom characters, and our map. There, they're all above 8,000 hex, or 8,000 and above. I mean, I don't think it would make any difference when we ran the program. We can have a look. Nope, we've just got less garbage on the screen now. Because we haven't got a lot of custom characters. Okay. First thing we can do then is draw our map. Okay. Now the way we're going to do this is a way I sort of I've been looking at a lot of different ways, and this I found to be quite a good technique. It's called self-modifying code. That's where you have a command to load from a memory address and save to a memory address, but then the code will then modify that memory address that it's loading to and from in the code, and then it will go back and run it again. Let me explain what I mean. So let's do a draw map. Okay, we'll make that like a function, because that's how I code things at work. Okay, so what we will do, we will load the X register with 0. Quit that. Okay. And then what I'll do, I'll tell you what I will do. I will put our self-modifying areas of code just down here. Okay, so we've got self-mod map. This bit of code will load from the accumulator. An address, I'll make it quite a high one. It can be anything. By the time the program will run this will have something completely different in it. Okay, and we'll do self-mod screen, and we'll store the accumulator. Okay, so this is loading something from the map and saving it somewhere on the screen. Okay, so let's populate these with the right addresses. Okay, so if we imagine this as hex code in the computer's memory, self-mod map is this. Self-mod map, this part of the address is map plus 2, because don't forget it's the other way around. And this part of the address is self mod map plus 1. So in the memory for this, let's go on to this line here. It will look like this. A9 for load accumulator. Okay, and then it will have EF and then BE. Okay. Don't ask me what the comma X is. It doesn't matter. That's not the bit we're modifying. We are modifying this. We want it to run that command, but we want it to run on whatever we put into these two memory addresses. Okay. So first thing we'll do then is we'll load the high byte of the address. Okay, which would be this. Actually, no, we'll do the low byte of the address, which would be this, because it's low byte, high byte, so it's actually FE and BE. No, EF and BE, sorry, in the memory, as I showed you. So that's where the map starts. Okay, and we'll store that. And I'll show you this working on using the debugger. So self mod map plus 1, which is here. Okay. Or here, if we're going to be exactly right. Okay, so we'll do this, we'll copy this and do the same. But instead we'll get the high byte of the address, the starting address of the map, and we'll store it in +2. Right, should we see that working? So let's pop a break here. Okay, and we'll load our debugger. I just realised I haven't been zooming, have I? Here's our debugger. Hopefully we can all see that. Okay. Okay, so it's stopped here, ready for a draw map. That load LDX0 is a load. Okay, and if you can see down here, let's just try and zoom in a bit. Okay, oh, but I've lost my cursor, so I'll have to zoom out. Let's see if we can stretch it. That's better. So this is our commands here. The load accumulator with the low byte, the memory address, the start of the map, which we know is 8000 hex. Store it here, and then the high byte, it loads, which is there, and store it here. So let's watch this 104B. Let's watch this line change as we step through the commands. Oh, it's not letting me do it. Okay, I might just do a jump cut while I fix this. Right. Okay. Yes. Idiotic, stupid mistake, and probably had a lot of you screaming at your computers. Obviously, it was stuck in this loop, and I didn't call draw map. So I've just done a JSR draw map before we do the loop. Okay. So let's just run the debugger again so you can see what it's doing. This is just, okay. So it's done everything. It's set our colors and our VIX settings and all that. So we're now at this load accumulator 0, store it here, load accumulator 18, store it there, which is getting from the low and the high bit of the start of the map. So we proceed over it, watch where it says load accumulator beef. Okay. So we will do F10, F10. See, now it says BE00. Load accumulator 80, which is the high bit, store it afterwards because it's in low high order, but it doesn't display that on the screen. As you can see now, we've got load accumulator 8000, which is the start of the map. We haven't done store and accumulate at the start of the screen RAM yet because I haven't written the commands to do that. But we'll do that now and then we'll check that again. Okay. So let's zoom in there so we can see it. So let's just copy this. That's the beauty of a modern development environment. We've got all this copying and pasting. So this is going to be screen RAM. So our new location for where the screen is. And we're going to put that in self-mod screen. There we go. Simple as that. So that'll modify this to have the correct addresses. And then what we can do, we can go back and keep going back and, you know, modify that. We can modify these. You get what I mean? We can modify these on the fly and then jump back and run them and it will load whatever we've modified this to. That's self-modifying code. So let's run that and just check it does what we say it will do. Right, so the first bit, we wanted to set this to 8000 and this to C000. So let's just step through these. That's the first one. There we go. So that's exactly what we want. So it will load the first character from the map and it will store it in the first character of screen memory. Okay, so what are we going to do? Okay, so we want this to run 40 times to do a row, yeah? And 25 times to do a column. Okay, so let's do some looping, okay? And what I'm going to do is I'm going to use 0-page RAM instead of the Y register, and I will show you about that in a minute. Okay, so what I'm going to do for the line counts, okay, I'm going to load the accumulator. There's 25 lines. And we'll store it into 0-page because it's nice and fast, because we want drawing maps nice and fast. That's 0-page, 00FF, it's free, we don't use it. Okay, and then we're going to start a loop going. So this will be the maybe an outer loop. Inner loop would be each column. So I'll do first outer loop is row 0. Second outer loop is column 1, or was column 0, then 1 until it gets to column 39, 0 to 39, and then the outer loop will run, and it will be row 1 instead of row 0, because everything starts from 0, not 1, as we know. So outer. Okay, so let's put that on there. So the first thing we'll use the X register as an index for this. So we'll load the X register with 39 because there's 40 columns, 0 to 39. Okay, and we'll inner loop. Okay, here. Okay, so we can tab this out a bit so you get a better sort of idea of how the loops are working. So outer loop is there, inner loop is here. Okay, so we've done our self-modified code. Okay, so then what we will do, okay, is we will decrease the X register by 1. Okay, and then BPL, which is if it will get to 0 and branch is plus, inner loop. Okay. So this will do our first row. We don't have to modify any of this yet because it's doing 0 to 39 for both. Okay, now here comes the fun part. You see, I deliberately made the map 256 characters long, which is one high byte. Okay. Okay, so if we look at the self mod map, see this address, which is 8,000. Okay, this is our low byte. Okay, and this is our high byte here. Okay, but obviously when we go to the next line, because it's 256, we're literally just increasing this by 1 to add 256 to this address. Nice and easy. So we're actually increasing this memory, this by 1, this value by 1, which is in this memory address. Self mod map plus 1. So that makes it nice and easy, doesn't it? So what we need to do is different with this, because we're adding 40 every time, because the screen memory is rows of 40, not rows of 256. There's a bit different with this. Okay. So let's add this by 40, yeah? So we'll clear the carry. We'll do a 16-bit addition. So we'll load accumulator self mod screen plus 1. So, okay, which is this bit here. It's the low byte. Add with the carry 40 to it. Oops. Okay, and we'll store that in self mod screen 1. So increasing this by 40, yeah. Okay, but if it goes over 256, okay, it will reset back. So say this was 250, this was 255, which is FF. We increased it by 40. It should then go to whatever is hex for 39, 25, I think, or 24. Okay, so we want that to roll over, but we'll get a carry bit left over. And that carry bit we want to add into this. Okay, so there's an easy way to do that. Okay, so it increases this in. So we want to increase this entire thing by 40. So we're doing the addition in 2 steps: low byte, then high byte. Okay. Okay, so what I want to do is branch if the carry is clear, which means it didn't exceed 255. That means we're done. And we want to let's put another label in here. Carry clear. The branch of the carry clear is 2. Carry clear. Okay, if the carry clear is not, oh, sorry, it's plus because we're going downwards. If it's not, we just want to increase this by 1. So we just do an ink command. We don't have to do another addition. We just ink self mod screen, and it's plus 2 because these are around the wrong way inside the memory. Okay, so that's plus 0, that's plus 1, that's plus 2. Oops, not that won't make any difference. Okay, so that'll increase that. Okay, so obviously then it will carry on to what we've got under carry clear. Yeah. So then we want to just increase this by 1. We don't need to increase this at all because it's going up in increments of 256. So we'll increment self mod, it's the map this time. We'll increment that plus 2. Okay. Then we'll decrease our 0 page RAM, which is like the Y register, but we're using this instead. And if it doesn't get to 0, we will go to the outer loop, and it's behind us, above us, so we do a minus. Okay. And then we'll do an RTS. Okay. Now, this should, in theory, draw our map with one thing missing. Okay. So let's run it, see what mistakes I've made. Oh, I've still got my break, haven't I? There we go. There's our map, but something doesn't quite look right with that. And you know what it is, don't you? We haven't done the colour attributes. We have not put the colour attribute into colour RAM. That's naughty of us, isn't it? Okay, so as you can remember from previously, the way colour attributes works is, say, just pretend this is our map, okay? And we have character 0. It will just look up the attributes for that in the first one. So if it was this one, AA, it would look up whatever AA is in decimal along and get attributes, okay? So this one, character 02, it would look up 000102, and that'll be its attributes. So what we've got to do is we've got to get 1,000 lots of these to put them into character memory, color memory. I'm sorry. Okay. So even though there's only this many attributes, we've got to fill our color memory with the correct ones that go with the character that's in the map. Okay. So let us. This is why we are. We have not used the Y register because I'm about to use it now. Okay. We've got our character, we've loaded it from the map, we've stored it into our screen mem, it's still in the accumulator. Okay, so what we do is we transfer the accumulator to the Y register because that value, say it's character 05, that means it's 0, 1, 2, 3, 4, 5 in our the sixth one along, because they start from 0 in our list of character attributes. So we now have got an index in the Y register of where our character attribute should be. So we'll just load it into the accumulator, character attribute data, Y. Okay. Oh. Okay. And we will store it self-mod color. Okay, we will store that in there, X, because the index is the same. So it's X is our row. This gets modified, so it would be the same row as these others. It's got to correspond with the area of the screen. Okay, so that's going to be exactly the same. Okay, so we could theoretically use these, duplicate exactly what we've got here. Okay, color memory is a constant. Okay, no matter where you move the Vic bank around, and I do have that saved in our Vic constants. So let's just copy this 4 lines. Zoom in a bit so you can see 4 lines here. It's color mem. So, and this is self mod color. Okay, I'm just copying that to here. Right. So let's just zoom out a bit and we'll check this. Okay, we've got our break there. Okay. Load our debugger. Okay. So that there's our load from the map here. Store in the screen. Load from where the character attributes are, which is 9900 because it's after the map. Store in the color RAM. Obviously, the color RAM is not populated yet. So let's just waltz over that to. That's done our map. That's done our screen RAM. Okay, and that should have done our color RAM, which is D800, of course, which is always the same. Okay, so one thing we haven't done is we haven't done any modification of this, have we? Okay, so this is going to be exactly the same as what happens with the screen because it's corresponding exactly to it. So the 40, if we're on the 40th screen mem character, we're going to be on the 40th color memory character. Okay, so anything we do the screen, we're going to do with this when we modify it. Okay, so we're going to store it into self-mod color. Okay, and we'll increase this if the carry is not clear. I'm not zoomed in enough. Okay, and the rest is done. That should be it. So let's run that. Oh, we've got our break. That's better. See, there we go. We do have a nice, nice colourful screen again. Exactly right. We've drawn this row by row. We've drawn it row by row. We've used self-modified code, which saves memory and does keep things nice and fast. And yes, we've done it with a map that's longer than 40 columns, even though we're using 40 by 25 screen. Okay, so the last thing we'll do for this video is actually get this to scroll. Let's look at doing a little scroll routine. Right, let's take this breakpoint out. Okay, save that. At the moment, we draw our map and then we just are stuck in a loop. So we only need to call this draw map once, okay? The way it is. Okay, it's very quick. So what we'll try and do is make the screen scroll leftways, but as though we're going right. Okay, we won't attach it to an event or anything like that. We'll just scroll it and then loop it round on itself, so it's almost infinite. I mean, that should demonstrate the principles of scrolling enough for this video. So, okay, let's see what we need to do. So if we look at our map on here, what I'd like to do is get, for each row, we'll put this square here, there, that there, that there. So shift them all along by one. Obviously, we do that on the screen memory. Won't know anything about what's to come after that, but we'll address that separately. Okay, so let's do that first. Okay, so get that doing that. So we need to do it 40 times by 25 times. Actually, no. Look, how many lines are there? That's it, right? So yeah, look, we only have to do it up to here. So we'll say we'll just do it 20 lines and we'll just leave these free. Okay, for now. Now, this normally shows us our map position, but it doesn't seem to be doing that. What column we're on. Hey ho! Back to our code. So let's add this to our loop. Okay. So what we'll do, let's do another function. It's not a function, it's a subroutine, but I program in modern languages. So we'll call it shift map right. So it's actually shifting left, but it's moving to the right of the map. Okay, so what we're going to do is we're going to do another technique of kick assembler called a rollout loop, and where this is where we can code a loop that looks like it's done in a modern language, and then we use the values from the loop and repeat the code inside that. And I'll show you how we're going to do that. Okay, so because it's a kick assembler function rather than a 6502, it will then translate this for us. So we're going to do for, this is our for loop, bar I equals 0, I is less than 20, because we're going to do 20 rows. We don't need to do the full lot, and I plus plus. Okay. So what this will do, it will loop through 20 times. So all the time I is 0 and I is less than 20. So between 0 and 19, I will increase by 1 for each iteration of the loop. And then each time it's in the loop, it will generate this code. So if I did LDA I, for example, okay, all like that, okay, it doesn't matter, I would get 20 lines of code, and LDA 0, LDA 1, right up until 19. That's what it will do, and that's the idea of this. It saves us typing it out 20 times and just increasing it by 1 each time. Okay, so in this loop, we want to load screen RAM. So we want to load from the screen RAM. Oh, actually, no, we need an inner loop, don't we? This is just going to do the rows. So this is the outer loop for the rows. We need the columns, don't we? Okay, so let's do another for. So we're nesting these loops. J equals, we want J from 0 to 39, because these are our columns. So less than 40. Okay, so that'd be between 0 and 39, and it'll increase by 1 each time. If we wanted it by 2, we'd do that. Okay, each time, but we wouldn't increase by 1 each time. Okay, so we will now get whatever code we're going to do. It will repeat 1,000 times, which is 20 times 40. 20, yeah, not 1,000. It'd be 800 times. 20 by times 40. So it does generate a lot of code for this, but it's going to be quite basic code, and it should flick through it pretty damn quickly. So what we want to do is we want to load the screen RAM, the next position along from the index, and store it in the index. So the way we'll do that, so we'll do the screen RAM or plus, and we want to know what row it is and column it is. So 40, it will be whatever row, it'll be this. If it's row 0, it's 0. If it's row 1, this will be 40. So plus 40 times I. Okay. So the first two, 40 times I is 0, it will be plus nothing. The next iteration of I, it will be 40 times 1, so it will be 40. Then the next iteration of I, it will be 40 times 2, which would be 80. So it will do each row at a time. Okay. Then we want to add the column in. That's J. So it will do the rule of, I think, BODMAS, where it will do the multiplication first, and then it'll add J on. So it'll be 0 for the first column, 1 for the second column, right up until 39. And then, because we want to take the next one, we add another 1 to it. Okay, because we want to take the next value on and store it in the current value. So we're taking this value here and we're storing it here. This value here, storing it here. Okay, so that's our index. That's our index plus 1, and we're going to store it there. Okay, so we will just copy that, and we'll store that. Oh, we'll store that, and just so you can see, plus 0. Okay, we're going to do the same with our. Let's do our color attributes. Actually, now we'll do this first, just make sure it all works. Okay. So that's that loop. Okay, so that's the inner loop. And then so that's our inner loop. So it will do all the way along. Obviously, column 39 will have a duplicate of what's in column 38 now, because we need to load into the last column the next part of the map. So we'll call it column 40, is 0 to 39, but we want column 40, we need to load into column 39. Column 40 is invisible on the map, because it's part of the map, goes up to column 255. So we want to load column 40 into column 39. Okay, so the way we'll do that is load from the map plus 256 times I. So the first iteration, it will be 0. Okay. And then go on X. Notice we're doing a plus here. Okay. So we're loading, adding it plus 256 on X. We'll store that in screen RAM plus 40 times I plus 39. Okay, so we're getting 40, and this is whatever row we're on. Okay, I, so on row 0. Okay, and then we're storing it in 39. Okay, let's give that a go. Let's see how this works. Okay, so in our loop, you know what we haven't done? We haven't set our offset, which is X. Okay, so how we need to sort of increase that to increase our offset. Otherwise, this will do nothing here. Okay, so each time we move along, we want to increase this by 1. Our map is only 256 columns anyway, so we can fit that in 1 byte. So let's put a byte here. How are we going to do this? Do it after this. Map position. Okay, let's scroll down. This will be a byte, and it'll be 0. Okay, byte of 0. Okay. So if we want to shift our map along, okay, to get the next column, proper column, we need this offset. We need to increase that by 1 and load it into the X register. So if we go back to our loop here, okay, what we should do was we'll increase the map position, map position. Okay, so we'll increase this value by 1. Okay, we will load it into the X register. Okay, so we'll load the contents of this into the X register. Okay, and then we'll JSR to shift map right. So it would help if we put an RTS in here. This should be screen in here. We'll do the colour in a minute. Okay. Right, shall we have a look at this? So this loop will increase the map position, load it to the X accumulator, jump to the shift map right, and then loop around, okay? And then when this gets to greater than 256, it will start at 0 again, so the map will loop round. Okay, we'll set the carry flag, but it doesn't matter. Okay, let's see what mistakes I've made then. Oh, and it's doing absolutely nothing. Okay, let me have a look at what I've done wrong here. Okay, I spotted my mistake. This RTS is in completely the wrong place, so we're only doing the top row, which we can't see. So RTS needs to go here. So it's in our for loop. Oh yeah, we did it so before we could iterate through this. So RTS should go there. So let's give that a go. Take our break off. Oh, we've got our brakes on, so we're not seeing anything. Let's just take that off. Rerun it. Oh, there we go. Oh, blimey, that is fast, isn't it? And there's as you can see, everything's moving here, but the colours aren't moving. Okay, the colours are not moving at all. Okay, because we haven't moved the colour RAM. Okay, so we'll do exactly what we did before. Okay, so from here, we've got the right value in the accumulator. We'll transfer it to the Y. Load the accumulator with the character attribute data from a Y, and we'll store that in the same way as this, but in color RAM, color rep mem. Okay, we'll do the same here, exactly the same. Oh. Okay, so yeah, doing exactly the same with our colour ramp. So let's run that. That's better. Look at that. It's still very glitchy. I'll tell you why. I'll tell you why that is, because we're not waiting for raster interrupt. Okay, so this is just doing it as soon as it can. So it doesn't matter where the raster bar is up and down here. Okay, it's just doing it. So what we want to do is probably wait for the raster line to get to about sort of here before we start redrawing it, because we start at the top. So that's easy enough to do. Okay, so we'll go to our loop. And what we'll do, we'll wait for the raster to get to line 255. Okay, so we do that just by loading. That's 255, it's in hex. We compare that with whatever's in the raster line. And we B and E. We've done an inner loop. We'll just go back 3. So that it will go back, back to here. Okay, we'll keep doing that. Go back three addresses. It will keep doing that until oh no, let's go back here. Sorry, do 1, 2, 3. Yeah, keep going back. Go back here. Keep comparing what's in the accumulator to the raster line. Okay, and once it is to 2FF, then it will run this. So let's run this. Oh, see, now that's better. It's nice and smooth, yeah. Right. Okay, so that's shifting right. We got it on an infinite loop. It's not using, the reason it looks a little bit choppy, we're not using the hardware scrolling at all for this. Okay. What can I do quickly? Should we look at shifting it left? That should be easy enough to do. Oh, it's the wrong zoom. Let's copy this. We'll change this to ship map left. So all we've got to do is work all this backwards. Okay, simple as that. Okay. So let's cut this out and put it at the top, because doing everything backwards. Control X. Why isn't it doing a cut? Control X. Okay. This will be not plus 39. It'll just be like that. Okay. This will go backwards. So we'll do from no, this will be the same, because it's going to go from the top row down. That'll be the same. Take this off. Okay. And then this will go backwards, because we're taking this here and putting it there. So this would be J equals 40, yeah, 40, isn't it? J equals 40. J is greater than or equal to 0. It's got a 40 to 1, because it's a 1 column ahead, isn't it? Okay, and J minus 1 each time. Okay, so we just want to switch these round to 0 and 1. And this one is that's one. Okay, I think that should do it. So let's, oh, how many pluses do we want? Let's go up here, okay, and we'll just change our loop slightly to do, so what we'll do is copy that out, we'll comment that out so we can switch between them. We'll decrease the map position, okay, and we'll JSR to shift map left. Okay, so forget that. Obviously you'd have both functions in here. If you've got a character you want to move, left and right. I mean, normally platform scrollers only scroll one way, like Mario is obviously you start off on the left and you scroll along to the right. But we'll just put both of these in here so we can see the difference. Right, let's see if it works. There we go, it's scrolling the other way now. Easy as that. Right, okay, well, I think we will wrap this video up here. We've done quite a bit. It's not the most efficient way of doing it in the amount of code, because don't forget, this lot here, well, yes, this here is going to be repeated 800 times, and this here is going to be repeated 20 times. So, yes, there's quite a lot. The 800, this is 820 lots of this lot, so it's taken out quite a bit of code. There are other ways to do it, of course. We can do something similar to what we did here with the self-modding. But I did it this way because I've looked at lots of other tutorials online and in some books, and this looked by far the sort of simplest if your assembler supports it. And unless you've got a lot of memory used up by game logic, extra sprites, bigger maps, etc., then this should be all right. Okay, we obviously it all fitted in our memory. Okay, if we look down here, okay, these are all our sections here. There's not a huge amount of memory. This is our code memory. This is our character memory, and this is our map memory. Okay, so we've got lots of room. Got another 2K, 2000, well, hex. We can go here, in between there. But then there is, you can make this more efficient at some point. But anyway, we'll wrap the video up here. I hope I wasn't going too fast and it was simple enough to follow. And what we will do on part 2 is we will look at making that scroll smoothly using the hardware scroll registers. Okay, so until the next one, and we'll see you soon. Bye-bye.